All right, so in this video, we are going to wrap up section 1.4. Remember, in the last 15-minute video, we talked about introduction to quadratic equations, and we solved those using the zero product property and the square root property. In this video, we're going to continue talking about quadratic equations. So remember, we have the form ax squared plus bx plus c equals 0. In this video, it's going to be very important with this technique to make sure we realize where those three numbers are coming from. Your a value goes in front of the x squared term, your b value goes in front of the x term, and your c value is the number by itself. Once again, remember, you must set this equal to 0 before you can start these problems. We are going to look at one of the more popular formulas, but sometimes a little bit harder for students to learn. That's called the quadratic formula. This is kind of a catch-all rule in the fact that if you can't figure out whether it's a factoring problem or whether it's a square root property, you can always resort back to this technique because it always works. But the downfall is that it does take a little bit of time to work out the entire problem. So let's talk about what this quadratic formula is and how we use it. So the quadratic formula is this beautiful red formula here on your screen. It involves the a, the b, and the c value of your quadratic equation. And it's essentially you just taking those three numbers, plugging them into this formula, and simplifying. So the formula that you will need to know, and I do suggest you write it down so you can use it on your quiz, but for your test you have to know it. It is the formula of negative b plus or minus the square root of b squared minus 4ac, and all of that will be divided by 2 times a. I will point out you'll see a very similar symbol that we had in the last video with the square root property, and that's the plus or minus symbol. Since there are usually two solutions for every quadratic equation, you will have to work this out with a plus answer and a minus answer because both of them will be solutions. So here on this slide, let's work an example very carefully and so you can see where all the values come from, and then we'll do a couple more on the next slide that I might go a little bit quicker through. So number 9, because we're kind of continuing on our talk from the last video, you've got 5x squared plus 3x minus 1. Now, since this formula is already written as equal to 0, we can immediately find our a, b, and c value. Your a value will always be the number in front of x squared, which is 5. B will be the number in front of x, which is positive 3. And c is the number that's by itself, which in this problem is negative 1. All we are going to do is we are going to take this quadratic formula and we are going to plug the three values in and then simplify. So for us, we will end up getting x equals negative b. So for us, that would be negative 3 plus or minus the square root of your b value squared minus 4 times your a value times your c value, which is 5 and negative 1. All of that divided by 2 times a, which is going to be 2 times positive 5. Right? Use your calculator where you need to, but you do need to simplify this a little bit. So you will end up getting negative 3 plus or minus the square root. 3 squared is 9. Negative 4 times positive 5 times negative 1 would be positive 20. All divided by 2 times 5 is 10. And if I add those two numbers together inside the square root, we get negative 3 plus or minus the square root of 29 divided by 10. Now, just like I told you in the last video, you'll have to write this as two separate answers. And so what we will notice is that our x value will equal negative 3 plus root 29 over 10, and it will also equal negative 3 minus root 29 over 10. Typically, we would try to simplify the square root term like we've seen in previous videos, but you can try your best here and with all your might, but you're not going to be able to break down the square root of 29 any further because 29 is only going to be equal to 29 times 1, which makes it a prime number, so it does not simplify inside of the square root. So therefore, your two answers to number 9 would be these two values we just wrote down. And that's what it is. It's all about finding your A, B, and C, knowing your formula, and substituting the values in. All right, so let's do a couple of more using the quadratic formula. And so while you get these problems written down, or if you need to pause the video to do that, I'm going to write down the quadratic formula here just so I don't have to keep scrolling back up and down as we work these problems. So there's my quadratic formula. And so I'd like you to solve these two problems with me. Number 10, you've got 3x squared minus 4x minus 1 equals 0. So the good news with this one, once again, is that you already have that equals 0 term on the right, so you can immediately label your A, B, and C. So for this problem, our A value would be 3, our B value would be -4, and our C value would be -1. Take these three numbers and let's plug them into our quadratic formula. So we will have x equals -b, so that's negative of a -4, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So if I were to clean this up a little bit, we should know that a double negative makes it positive, so that's +4, plus or minus the square root. Let's see, -4 times -4 would make that +16. -4 times +3 times -1 is +12, divided by 2 times 3 is 6, which if I add those two numbers together inside the square root, 16 plus 12 will give me a 28, and then everything else stays the same. Now, unlike the last one where we just stopped and this was our answer, the difference this time is that I believe the square root of 28 is actually going to simplify. So remember, when you're simplifying square roots, you're going to make a factor tree. So we're going to take the 28 and we're going to break it down into as many multiples as we can. So we are going to end up having that 28 is 7 times 4. 7 doesn't break down any further, but I know that 4 breaks down into 2 times 2. And remember, with square roots, it's all about looking for pairs. So we will have, notice that there's a pair of 2's here. And so when I go to rewrite this problem, it becomes 4 plus or minus. The pair of 2's that you have circled can come out to the front, and any numbers that you don't circle, which in this case is a 7, stay inside the square root. And so that becomes 2 square roots of 7, and it's still being divided by 6. Lastly, you will notice that if you look at all three numbers that are left, the 4, the 2 root 7, and the 6, all of those share a number in common. They all share a 2 in common, so we can divide each of those numbers by 2 to simplify even further. So the 4 will be divided by 2 to become 2. This 2 actually just cancels because it is a 2, and then the 6 on the bottom will become a 3. And if we were to write this out, this would be 2 plus or minus the square root of 7 divided by 3. And so remember, on your homework, you'll have to write this as separate answers. So you'll have 2 plus root 7 over 3 and 2 minus root 7 over 3. That is your two solutions for number 10. Number 11 is the same approach, but you probably already have noticed that it is slightly different in the fact that you don't have a 0 on the right-hand side. So before we can set up the quadratic formula, I need to move that -1 back to the other side of the equation. So we can do that by simply adding 1 to both sides. That will give us 5x squared minus 3x plus 1 is now equal to 0. And now we can label our A, B, and C value. So in this case, A will be 5, B will be -3, and C will be +1. So when I plug those into my quadratic formula. Let's use a different color here so it's easier. Let's use green this time. So we're going to have x equals negative b, so negative of a negative 3, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So if we were to clean this up a little bit, a double negative becomes positive 3. Inside of the square root, negative 3 times negative 3 is 9. And then negative 4 times 5 times 1 would be negative 20. All over 2 times 5 is 10. And if I combine the two numbers inside of my square root, 9 minus 20 is negative 11, all still being divided by 10. Now, you might remember from a few videos ago, we talked a lot about the square root of negative numbers, all right? And so when you run into the square root of a negative number, remember, root negative 11, we could think of this as the same thing as the square root of negative 1 times the square root of 11. And we do that because we know from definitions that the square root of negative 1 is going to be I, the imaginary unit, and then we'll just bring down the root 11 because it doesn't simplify any further because it's also a prime number like we saw earlier. That's the big difference. That's as far as you can simplify this, but you have to remember separate the plus and minus terms. So we would say that x is equal to 3 plus I root 11 over 10, and also 3 minus I root 11 over 10. And so that's an example where you can use the quadratic formula, but you actually end up getting complex number answers because they include this imaginary unit. All right. So that's the 3 techniques that you should know in order to solve any quadratic equations. But what I want to show you here at the very end of this video is that sometimes it will not tell you what technique you have to use. And so I made up 2 problems for the video that I'm going to talk through how I decide which technique I think is best. So for these 2 problems, I'm just going to talk through how I would work the problems without having a set way that the problem is telling me to do it. So beginning with number 12, you've got 4x squared plus 4x plus 1 equals 0. Now immediately I like the equals 0 on the right, so it's already in the right format. And I also notice that it has an x squared, an x, and a number. So the one rule that I know does not work here is the square root property. So the 2 techniques you could try here are either trying to factor it or just going straight to the quadratic formula. Honestly, what I've noticed from students in the past is that unless it's a very easy factoring problem, most students don't go that route and they prefer to just do the quadratic formula, which is perfectly fine. Remember that the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And just like the last 3 problems we've done, we can actually label our A, our B, and our C here, where A is 4, B is also 4, and C would be 1. And so if you like this formula and you're willing to learn it for your test, you can work any problem as long as you just know the formula and you plug your numbers in correctly. So if I do that here, this would be x equals negative b, which would be negative 4, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. If I were to simplify this, this would be negative 4 plus or minus the square root. 4 squared is 16. Negative 4 times positive 4 times positive 1 is negative 16 over 2 times 4 is 8. And voila, this actually came out to be very nice because I know that 16 minus 16 is going to be 0, and the square root of 0 is just going to be 0. So I can actually just cancel that part out. And since this goes to 0, we don't even need the plus or minus anymore because adding 0 and subtracting 0 doesn't do anything. So all you're left with is x equals a -4 on top and 8 on the bottom. And since both of those numbers share a 4 in common, I can divide both numbers by 4. And this will simplify into an answer of -1/2. That is the only solution of number 12, and we use the quadratic formula to find that. One more where I'm not going to use the quadratic formula on is number 13. It says 3x squared minus 12x is equal to 0. Now, once again, I also am not going to use the square root property here because there's not an x squared and a number. Since there's an x term you can see attached to the -12, that throws out the square root property. Instead, you either have to go with factoring or you have to go with quadratic formula. On this one, I'm just going to choose to not do the quadratic formula just to be different, but you're more than welcome to do it in this case. Instead, what I'm going to show you is that if you notice that it factors, go ahead and do that. 3x squared minus 12x, I can actually factor this using greatest common factor because I noticed that both of those terms share not only a 3 in common, but they also share an x in common. And so if I take a 3x out of both terms, you will have an x left over in the first term, and you will have a 4 left over in the second term while also bringing the minus down. Remember from the last video is if you can break this down into two things multiplied together, the zero product property says you can set each of these equal to 0 separately. So I'm going to set 3x equal to 0 and x minus 4 equal to 0. On the first one, if I were to divide both sides by 3, it actually doesn't do much. So you get an answer of 0. And on the second one, if I were to add 4 to both sides, that would give me a second solution of x equals +4. And so that one I chose to solve by factoring instead of trying to solve it by the quadratic formula. And so that actually wraps up my second video for section 1.4. Over the last two videos, we've looked at 3 different techniques of how to solve quadratic equations. So make sure you're reviewing those as you do your homework. In the next set of videos, we're going to jump into section 1.6, where we look at a few weird equations. And so you're going to see that the title of that section is a little bit different, but we're going to look at kind of some oddball situations that we might run into in this class.